everyone. Hi, I'm Goutham. I'm a product manager by day, but I still like writing code, so I'm a software engineer by night, or at least I like to think that I am. Yeah.
Hi, I'm Jesús. I'm a software engineer at Grafana and Prometheus team member since this year. And over the last 2 years, I've been working on maintaining the TSDB, out-of-order support, and now OpenTelemetry, or trying to make Prometheus support OpenTelemetry natively. I'd like to start with this chart. So I took this screenshot a couple of days ago. This is the Grafana Cloud's growth in terms of the amount of organizations that are adopting or trying to use OTLP metrics. So this does not include traces or logs. It's just metrics. And we've seen a 2.5 times increase without much effort from our side. So it seems that there's interest in the community for this. And we're also getting questions about what's the status on the OTel SDKs, their support for sending metrics to Prometheus. And so it's a topic that's gaining traction, and yeah. But the thing is, for those of you who don't know, OpenTelemetry is a spec, so it defines how you're supposed to observe different observability signals, such as metrics, traces, or logs. But it doesn't provide a backend. And users that want to use their favorite metrics backend, Prometheus, when they try, they see that it's sometimes not the perfect fit. There's some things that don't work as expected, and also, yeah, maybe sometimes there are some samples dropped that shouldn't be dropped, and sometimes it's hard to see the actual data that you send it. Yeah, and that's the image that's the pull request that Julian was referring to earlier. That's the very, very, very experimental OTLP native ingestion endpoint that we have just added to Prometheus. So we're getting there. And now I leave it to Goutham to show you a quick demo where you can see some of these issues I was referring to.
Yeah, so basically, OpenTelemetry is a spec. It has a data model, and this is kind of how the OpenTelemetry data model looks like. For example, if you have a service that's pushing data, you have a bunch of attributes called resource attributes that kind of tell you details about where the service lives, what the service is about, and things like that. And then when this service or instance pushes metrics, these are normal metrics with labels, but it says, oh, all of these metrics are coming from this resource attribute with these resource attributes. The resource attributes are kind of like target labels in Prometheus, like Kubernetes cluster name, namespace name, and things like that. Cool. So now kind of let's look at how the spec defines this to be stored in Prometheus. So I have a Prometheus server running, and I instrumented, I instrumented one of my services to expose one metric, which is the HTTP request duration histogram. And if you kind of try to take a look at what this histogram looks like, it has the method, route, and status code. But it actually doesn't have any of the resource attributes that tell it where it is coming from. So the spec defines the resource attributes to be stored in a separate metric called target info. And the target info is this massive metric. For every instance, we just take all the resource attributes and put it in this target info metric. So now, if I want to use this information, let's try to use this information. It's going to be hilarious. You will see why. So I want to measure the rate of requests over the last 2 minutes, and I see, OK, there are different rates of requests. For hi, hello, 1 service is having some QPS and stuff like that, but I kind of want to see the rate of requests on a cluster basis, like on group by cluster. For this, I need to do something called joins. So let me try to join on target info. That won't work because, joins, who does them? Wish me luck here. Maybe this will work. Nope. I have to do something called group left. Oh, it did work, but not really. We need the cluster name. So I'm going to say, OK, group left by k8s cluster name. And the cluster name gets added. Now we do a sum by I love the autocomplete on this one. HTTP status code, and this big-ass query, and then I graph. And then I can kind of see, maybe for the last 10 minutes when I kept the demo running. Nope. Yeah. All right, so I can kind of see that prod US central 0 has 6.5 requests per second. Prod US 2 is lagging behind a little bit, and I can also see that, oh, only prod US central 0 is having 500 errors. So this is a very common use case. And this is the bonkers query that you have to write to handle this use case. I don't want to be writing these queries, and this is a simple thing to do. And suddenly it's super complex. Yes, there are ways to get around it. For example, the OpenTelemetry Prometheus exporter gives you a way to copy all the 40 resource attributes into every single metric. That is also not a great experience. So yeah, this is a highlight of what the current state is. Cool. Yeah.
Right.
Yeah. 1 second, I think you clicked that button. Yes.
Yeah. So it's time to build things and try to fix this. So you'll see this slide 2 times, one here and now, and then another time at the end. It has 3 links, so anyone interested in this topic that wants to contribute, you go to this slide and you'll find everything you need. First link has a list of like the UX issues we found, and like it's a public document, so like you can suggest, and if there's anything that you're already using this and there's something that is not mentioned, feel free to add it. The second link has a list of like all from the things from the first document, which ones we think are a must-have, like to be native and a great experience for the user. And then it has another list of things for like the nice-to-haves. So maybe not to do on the next year, but over the course of time, you know. And the third thing is the thing we are working now, which is we are trying to map all those issues into the Prometheus tracker. So there is a milestone called OTel support, I think. And yeah, we are mapping all those issues. So yeah, feel free to work on that. Help wanted, I'll be there. Right. Yeah, and we have, like, now we're going to dive in some of those issues, like to give you an overview of how what these issues look like. So the first thing is push versus pull. You know, Prometheus has always was meant with the pull-based approach, and that kind of gave us, there's a bunch of things that people don't think about, but for example, service discovery, like if you had 50 pods in your infrastructure, service discovery will find them, and if 2 were down, you will exactly know which 2 were down, because you know you have the names and everything. So that kind of gave you the app metric. And also, like if suddenly any of those pods got to a newer version and it started instrumenting like 1,000 new metrics, you could protect your Prometheus server by setting the right configuration so it wouldn't crash, because like you have limits configured, and if you scrape those pods, like it will just protect your server, right? So you would have, you would know which services, like it would be a more reliable setup because you know which pods are up, which are down, and also, yeah, if they go beyond the limits, you're safe, right? But with the push approach from the OTel native instrumented applications, you don't have those protections because you don't have, you don't know which are up or down because you're not like service discovering them, and also you don't have like the app metric. But we think that we can build it. Like we can probably leverage the service discovery. Like we can do a mix of service discovery with the push-based approach because in OTel like recommends to from the SDK when the metrics are pushed, like it pushes every 60 seconds. So we can, by adding some logic to Prometheus, we can know if a pod has missed like 2 intervals of push intervals, it's probably down. So we can just track the pods that are supposed to be there. We can just check which ones are sending data, and then we can have an app metric. So like we can build the same feature that we don't have right now. Yeah, and another thing, the pull-based approach only has configuration on the server side, but the push-based approach from OTel like would require configuration on the Prometheus side, but also on the clients. So like that's an overhead for the user, but yeah, so we would have to probably come up with decent documentation for the user. But so this is something also that needs to be done. Right. The second thing, proper handling of resource attributes. Like Goutham explained this very well in the demo. I underlined, so that's a P95, like histogram query. Most of you probably are familiar with. And we want to see like the P95 of that metric, and we want to see by availability zone. But because we don't have the availability zone on the series, we have to do the awful join. So yeah, so ideally this query would just work without the underline part. And as a Prometheus user, what I would do to achieve this is I would go to my code or wherever that metric is being produced, and I would put the availability zone into the series as a label, right? So this is precisely the feature that we want to give to users. We want to give like some sort of configuration for Prometheus where you can say, copy this list of resource attributes from the target info metric into my metric on ingestion time. So you don't have to do anything other than properly configure your Prometheus instance. And yeah, and we can, so there are a list of attributes that are default by the spec, but you can also have custom attributes. So you could add them to that config, and it would just happen. And then you won't have to do the joins. Right?
Yeah. The other interesting thing about OTel is it has support for dots in metric and label names. So whenever somebody defines http.server.request.duration in their code, when it ends up in Prometheus, we have to convert all the unsupported characters to underscores, which is confusing for developers. Why is what I'm defining not in Prometheus? So we are adding UTF-8 character support to Prometheus, but I do want to mention something. Why do I say it's UTF-8? That's because OTel supports UTF-8. This is a valid metric. It's not dividing service metric by version metric. This is a valid metric in OTel. And you can define this in the SDK. But this is also a valid metric in Prometheus. That's not service minus version. That's one metric name. But we will kind of have to support this because we don't know how users will be using OTel and how they will be defining their metrics or where these metrics are even defined. Cool. So yeah, we want to expand Prometheus to support most of the common use cases of the OTel character set. Yeah.
Yeah, out of order. This topic keeps coming back to me. So out of order, yeah, OTel instrumented applications typically write to a collector, and then the collector writes to the backend. And so this is because the collector encourages batching up writes. So like, I don't know, I want to receive 100 metrics before I send them. And the reason for this, it makes sense from the client perspective because then compression is more effective, and also you have less traffic, less total traffic over the wire, so it also optimizes for bandwidth usage. But the problem with this is that it puts pressure on the backend. You now have to handle higher payloads, and also the moment you have multiple collectors on your network, on your topology, you're probably going to have out of order because the collectors are not going to wait on each other to push the metrics. And also, the moment you have a failed request and you retry it, you're going to get out of order. So I think we cannot exist without it in the context of OTel. And it's not a blocker because, fortunately, we announced out of order as a feature in last PromCon in Munich. And it's working, but it's still experimental. So the work to be done here is probably to finalize policy in some of the rough edges. Like there's a bunch of issues. We have made sure to put those issues into the milestone. Yeah, and possibly produce some documentation as to if you're using OTLP writes like OTel ingestion, the native ingestion, like how you should configure your server to make it work, and probably just enable probably 5 to 10 minutes of out of order is enough.
Yeah, remote write. This is a format that has had major changes in a long time. But funnily, we only called it stable this year. So this is a benchmark of scraping 4 million active series and then sending them over OTLP and sending them over Prometheus. How many of you think that the blue line, which is the number of bytes or MB, is Prometheus? Okay, a few people. Well, it's not. It's actually OTLP. So OTLP uses 50% less egress compared to remote write. However, it uses zzip, which is mostly doing a lot of the work, while Prometheus uses snappy, which means you also use a lot more CPU. It's like 30 to 40% more CPU. And we actually made this comparison when we designed Remote Write 5 years ago. And at that point, we decided that CPU was more expensive than network. I think that is changing slowly, hopefully. So basically, we are looking into making Remote Write more efficient and maybe even adopting OTLP. One of the reasons for that is there's a new Arrow implementation of the OTLP protocol, which uses half the bandwidth of the non-Arrow implementation, while also using half the CPU of the non-Arrow implementation. I put an arrow there for the Arrow protocol. So this is also, I love the fact that this is happening. This is also pushing Prometheus to innovate more, and also we probably will have a Remote Write 2.0 because of this, and I'm really excited for that. Delta temporalities. 2 days ago, I published a blog post on delta versus cumulative temporalities and the trade-offs between the two. But the thing is, in OpenTelemetry, you have both cumulative metrics and delta metrics. How many of you understand the difference? OK, a few of you. So if your application is exposing a counter, HTTP request total, the way your application exposes it to Prometheus is the cumulative value. It's like 10, 20, 30, 40. It's like an ever-growing value. But if you're coming from a system like statsd, you actually push the deltas between the last value and now. And basically, OpenTelemetry supports both. And it says that the delta metrics are more efficient because you don't need to store state in your application. So if you see a delta of metrics, you just push it, and then you can kind of remove that metric from memory if it's not being updated quite a lot, which is fair. But I also see a lot more use cases for delta. This is an example of the delta. So the upwards is how the cumulative value looks like, and the downwards is the lower one is how the delta value looks like. How many of you tried monitoring Lambda services with Prometheus? Okay. Okay, nobody tried to monitor Lambda. Okay, interesting. It's a good reason, because then you would bang your head against a wall because Prometheus is not exactly built to monitor Lambda services. That's because with Lambda, you have an invocation ID, and the cardinality just blows up. And this is one example where Delta can kind of help you monitor things, where your applications just push Delta, and then in Prometheus, you aggregate that into the cumulative value. The other thing it will also help is aggregations and to reduce your cardinality. So yeah, we do want to support delta temporalities in Prometheus. Hopefully, we'll see. So we said time to build things, but honestly, it's time to build things after the dev summit on Saturday. Because a lot of the changes that we are proposing here, they're very exciting, but they're also massive changes. We are going to make Prometheus a push-based system. And this is a fundamental change to Prometheus. We are proposing to add delta temporality to Prometheus. This is also a massive change. So we have a nice discussion that's going to happen on Saturday, where I hope we get consensus to do a lot of these cool changes in Prometheus. And once we have approval for some of these changes, let's get hacking. So we have time. Is that with Q&A or without Q&A? Oh, it's without Q&A. Any questions so far? All right, you have a question. Yes.
Yeah, about making Prometheus push-based and the up metric. Some clarification would be good around, like, is that recommended to be using primarily with push, or should we, still tell Prometheus users to primarily use pull, which I'm a big fan of because of service discovery, and then coming to the up metric that was mentioned earlier, where just checking if an update doesn't come in twice, now it's down. We don't really know, is that supposed to be gone now, or did something that never pushed something, should we be able to detect that as well? Is there some kind of service discovery support for this path planned as well, so we can actually know what is currently supposed to be where?
That is a good question. So basically, it's going to work like pull, We discover everything that is supposed to be pushing, and then we watch for the pushes. If we don't see a push for 2 intervals, we mark it down. That is the plan. That is the idea in my head. Somebody needs to write a design doc to explore all of these. But what I really like in OpenTelemetry is that the client SDKs they're building a remote configuration protocol. And I'm hoping Prometheus can push down the configuration to the SDKs as well. So if Prometheus is becoming overwhelmed, you can say, don't push every 60 seconds, push every 120 seconds and stuff like that. So it is going to be a big shift, but I think we can make it work. But we have to see. Somebody needs to write this design doc and think about this for 3 days or 4 days. Yeah.
But you don't want to get rid of pull.
No. This is no. This is yes. Yeah.
Yeah.
Oh, so yeah. So Julius. No, I don't want to get rid of pull. I love pull. I'm going to try my level best to make sure that the best benefits of pull are existing in the OTel world as well.
So to correct there, to help answer your question as well, like we want to leverage the good things about pull that we already have, like service discovery and the app metric, and build that for the push-based approach, but not like replace one thing with the other, just like have both. Yeah.
Cool. We also had a question there. Yeah.
Slides?
No.
Okay.
The question is, which library for OpenTelemetry do you use in Prometheus? The official library of Go library from OpenTelemetry community?
So we don't use the instrumentation libraries in Prometheus at all, but we use the collector code, which converts from OTLP format to remote write format in Prometheus.
And then the question is how much the Prometheus binary size increased after you added this OTel library into Prometheus?
It's a good question. I have no idea, but I don't think it's a lot because Prometheus pulls in the universe already. So it shouldn't be a lot, yeah.
Why I'm asking this question? Because in our case, the binary size increased by 10 megabytes, and it was more than 50% of our binary.
Oh, wow, yeah. You had a question there, I think.
Nice. Lots of questions.
Oh, sorry,
For the bit you were talking about to do with the querying side of things, with the joins and what have you, you said about potentially changing things so that it added the labels in at ingestion time. Have you considered doing that at the query time instead? Because we already have this sort of issue to a certain degree where people are using machine metrics to do similar things, and therefore maybe doing it in the query to solve both or make it nicer for both use cases would be nicer instead of having to remember to do that, and then, oh, I've got old metrics that don't have that label and all that sort of pain there.
Jesús, you want to take it?
I don't know what to answer, really. So I think we thought about this, but then you have to like search like into more blocks, probably, right? And pull in more data and like abstract that complexity from the, I don't know. We feel that doing that on ingestion time would simplify things in the Prometheus code base itself, but yeah, this is a valid proposal. We actually, so the way this is going to come down is probably in the next month or month and a half. Like, we'd like to write a doc. And what we said is not like the definitive proposal, it's just one of the ideas. So, if you want, bring this as a proposal and we consider that. And yeah, I cannot answer right now, because we need to know the implications, what will be best, yeah.
One of the oldest issues in the Prometheus repo says, simplify joins, please. And I agree. But yeah, nobody has basically thought through this on how we can do that. And yeah, we would love to collaborate. Yeah, go for it.
Hello. In the milestone that you have in Prometheus repo to support OTel, is there anything that is very obvious that you need Prometheus 3.0?
I think there's nothing obvious other than adding documentation.
Give me a second. Prometheus 3.0 for this. maybe if you want to simplify how we support UTF-8. If you want, like, the current way is we have a proposal that's open. I quite like it. But if you want to make the dots and stuff native to PromQL and make it extremely simple to use other characters, I think that might require a 3.0. That might. We try really hard not to break things. I like the Go model where they say there will never be a go-to. Yeah.
Do we have more questions? Do we have more? Yeah. I mean, we have a break after this anyway, so, but we also want to take time for the break because we are going to have some bagels, I believe. What was the question?
So I'm not familiar with how the OTel protocol works, but when you talked about the push model, is there going to be support for UDP as well, or is it just strictly mostly TCP?
That's a good question. The OTLP has HTTP and gRPC, so they're both TCP. I don't think there's a UDP in there.
Gotcha.
An arrow? What does arrow?
That's also gRPC, I think.
gRPC.
Yeah.
Okay.
Yeah. One more question. Yeah.
You already had one, so first.
My question is, what are the benefits and the trade-offs of switching from push to from pull to push?
There are none, but so basically we are seeing customers and users and stuff, they are gravitating towards instrumenting with OTel because they like the premise of not having vendor lock-in. They like the fact that there are semantic conventions. And when you use OTel, the mental model that you use is push. OTel does support pull, but all the documentation says push. So it would be swimming against the tide and an uphill battle to convince users, hey, use OTel, but use pull with OTel. That's basically, when we are trying to be OTel native, we need to support push. But I don't see any benefits of push. But I'm also a long-time Prometheus maintainer, so I'm not biased at all.
We love pull. Pull is going to remain.
Yeah.
So you can keep
Do you
it.
have your question?
Except for deltas.
Oh, yeah, yes, except for deltas. Yeah.
You showed on one slide that OTel protocol requires less network bandwidth than Prometheus remote write protocol, and you're exploring that it would be great to add support for OTel protocol into into Prometheus. And the question is, probably it is better to just replace snappy protocol with the snappy compression with the SSD compression for Prometheus remote write protocol, and this also reduces network bandwidth by up to 5 times.
Yeah.
We already
So there is an effort.
experimented.
There is an effort for this. There is people. I think Callum couldn't make it because he's on PTO, but there's a document describing this for remote write 1.1, where like we are trying to add other compression algorithms, and then you can choose. So there's a group of people that's trying to build that and test it with remote write 1.1, yeah, and then produce a benchmark. And that should, I think we are close to that. It should happen.
I think that it's much easier than
Yes. So yeah, the comment is it's probably much easier to do that than use OTLP. I fully agree. I am putting this graph in front of everyone to kind of force people to be like, oh shit, we need to improve remote write. It doesn't need to be OTLP. If you can kind of come up with something that's better and faster than OTLP, let's do that, but not OTLP. But we should basically be more efficient, or at least as efficient as OTLP. Yeah.
Okay, that is it, I believe. Thank you so much for the both of you.
Thank you.